So, first thing I'm going to do is just read over the problem real quick, just to kind of get an idea of what's happening. So raising money for new football uniforms, selling school T-shirts. So there's just some information like context stuff. Nothing about the math though. Short sleeve T-shirts cost the school $5 each and are sold for $8. Long sleeve T-shirts cost the school $7 and are sold for $12. School spends a total of $2,500 and sells them for $4,200. And then there's the question: how many short sleeve shirts were sold? Okay. So just getting a feel for what's happening. Okay. But then that first thing we want to do is define those variables. And usually where you want to figure out what you're looking for is generally in that last, the questions at the end. Okay. There's the question, right? How many short sleeve T-shirts were sold? For whatever reason on this particular problem, they're not asking us both, because they are saying, the problem is about long sleeve T-shirts and short sleeve T-shirts. For whatever reason, the question's only asking about the short sleeve. Okay. But there's what they want to know. And your variables need to basically be questions, right? What is it that you're looking for? Okay. Well, we're looking for how many short sleeve T-shirts. So that basically means that's one of our variables. It's one of the things we don't know. Okay. We don't know how many short sleeve T-shirts are sold. So you have some choice here. Okay. You get to define your variables. That means you get to decide what letters you want to use. And you get to decide what order you put them in, but you don't get to decide what the question is. The question's already there. Okay. How many short sleeve T-shirts are sold? So if I want to use X and Y, I can use X and Y. If I wanted to use A and B, I could use A and B. Okay. I just generally use X and Y. And if I want to say that X is, deals with the short sleeve T-shirts, or I could say that X deals with the long sleeve T-shirts, that's up to me. Okay. But it's not enough just to say that X equals short sleeve. That's not a definition. That's not what the question is. Right? There's no question there. X equals short sleeve. What about the short sleeve? Right? What are you actually looking for? Is it the price? Is it the color? Is it, right? What is it? Right? So you guys really need to make sure you're paying attention to what the question wants to know. And that's, again, your variable should essentially be a question. So I could say, how many short sleeve T-shirts? I could say the amount of short sleeve T-shirts. Okay? The number of short sleeve T-shirts. Okay? That's what we need to know. So one of those phrases needs to be in your variable. Right? What is it about this thing you're looking for? So I could say how many. Then I say, short sleeve. Okay. And then the other one's also going to be how many. And even though they didn't ask us this, we have to know this in order to answer the question: how many long sleeve T-shirts, or the amount of long sleeve T-shirts, or the number of long sleeve T-shirts. Okay. So I get to choose what letters I pick. I get to choose what order I put these in. I don't really get to choose this. This is what the question is. Okay. So these things need to be there. You get to decide what letters, you get to decide what order. That's part of your defining. So now we know what we're looking for, right? Very specifically. Now I go back and I start kind of trying to pull things apart, see what I see. Okay? A lot of these questions, like when you're setting up these problems, you want to look for consistency. What is it that connects the variables? Right? We have two things we want to know. We have to have two equations, right? Two questions, we have to have two equations. So what's going to connect these things that I can make an equation out of? So as I look back, it talks about the cost of the T-shirts and also tells me what they sold for. And it talks about the cost of the T-shirts and tells me what they sold for. And it talks about total costs and total income. Okay. Well, what connects all those things? Okay. So Tatum's saying she took the 8 and the 12, and she related that to the 4,200 because that all dealt with how much money they were making. So when we use a word like each, Tatum, what's that telling you? What type of math is that when you say each? $8 each. Multiplication, right? So 8 times how many they sold, right? 12 times how many they sold would give us total income. So a connection, right? That they sold for this, or they sold for that, and then that's the money they made by selling things. So those are the ways of connecting things. Okay. 8x, and set 8 times the number of short sleeves, and 12y, because that's 12 times the number of long sleeves, would give us that $4,200. What do we need to do here? Plus, right? Yeah, the money you make from one plus the money you make from another would be a total amount. Okay? Whenever you talk about totaling, it's always about adding. So there's an income equation, right? What else do they talk about in the problem? Yeah, how much they spent, right? Costs of things. So, cost them this much each, cost them this much each, and then they spent this much money. You always see that word each. You see the word each, you see the word every, you see the word per. Those are all multiplication words, right? 5 times the number of shirts, 7 times the number of shirts. When you add that up, you should get this total cost, right? There's that word total. So there's our system of equations. Okay? This is where most of your mental energy needs to be spent, guys. Defining your variables and setting up your system. If you set up the system incorrectly, there's no way to solve it correctly. Okay? And solving the system should be the least of your worries. It should be something you guys are pretty comfortable with. So you get to decide how you want to do that, whether you're going to use the substitution method, whether you're going to use the elimination method. Okay? Remember, substitution method wants one of the variables to be alone. And to get one of these alone, we're going to have to do division by something we probably don't want to end up dividing by. So I really don't want to use substitution method in this problem, so I don't want to divide by any of these numbers here. So instead, that would tell me that I should do the elimination method, where I said I want to have opposite coefficients. I need to think about a number that they both go into. All right, 8 and 5 are smaller numbers. So I'd rather work with the 8 and the 5 than the 12 and the 7. But 8 and 5 don't have anything in common, which means that their least common multiple would be just their product. So 40 would be the smallest number that 8 and 5 both go into. So I'm going to need a positive 40 and I'm going to need a negative 40. So I'm just going to make a decision. I'm going to multiply that top equation by 5. I'm going to multiply the bottom equation by negative 8. Okay? You can multiply the top one by negative 5 and the bottom one by positive 8. It's up to you. Okay? I'm just making a decision. So that would give me 40x plus 60y. That's 21,000, I think. It'd be negative 40x minus 56y. Be negative 20,000. Add those together, your x's should cancel. Leave you with 4 y's equals 1,000. So divide by 4. Y would be 250. But you know what y is, you plug it back into one of your equations up here. Figure out what x is. So I'm just going to do it in the first one. Eight x plus 12 times 250. 12 times 250 is 3,000. Subtracting 3,000 and divide by 8. 150? Okay. Jacob? It should all be, again, like the solving here that we're doing is, at such a lower level than the solving that we've done throughout the year that you guys should be comfortable with this. Just linear equation solving. So there we think, there's our answer, all right? 150, 250. So we're going to go back and check that using the RREF calculator, okay? So you need to take your system and rewrite it as a matrix. So you can plug it back into that calculator, which again I've linked for you guys in the Google Classroom. Remember write the row, so 8, 12, 4200. So just take the coefficients, have your augment bar there, and 5, 7, 2500. Do what way? We're going to check it. Better. Right, we're just doing our check. Yep, we're just going to plug it into the calculator to check it. So remember with the calculator, you need to know how big the matrix is, rows by columns, okay? So 2 rows, 3 columns, which is the default on the calculator. So it's 2 by 3, just need to plug in the values. That was what? 8, 12, 4200, 5 and 7, and then 2500. Put your little calculate parallelogram down there, like the computer noises in your head. And then we see our 150 and our 250, right, that we said. So 1, 0, 150, 0, 1, 250. Looks good to me. 1, 0, 150, 0, 1, 250. Which checks with what we had. So the last thing I'd like you guys to do is take those answers and put them back in context, right? What did X stand for? What did Y stand for? And I know the question only asks us for part of this, right? We do have both answers here. X stood for how many short sleeve, right? And Y stood for how many long sleeve. So it did just ask us about the short sleeve, so that's all I'll answer. But we could answer both, both parts. Right? So just take that and put it back in context. Right? That stood for the quantity of short sleeve t-shirts, right? Or the amount, right? Not price or anything like that. Still a short answer. Okay? When you guys were doing the exponential equations, I was telling you guys you need to label your answers, all that stuff. This would be a case where, like, if you got a decimal, you would be like, okay, this doesn't make sense. If I got a negative number, this doesn't make sense. Something that's going wrong. Okay? And you guys are checking your answers in the calculator anyways. But where that's going to go wrong is you're probably going to write the equation wrong. Okay? If you're getting the wrong answers, it's probably because you wrote the equation wrong. Especially when you go back and check it in the calculator, that's still giving you an answer that doesn't make sense, like a negative decimal, because you wrote the equation wrong. Okay? And that really is where most of your mental energy needs to be spent here today. How do I write these equations? So there is about consistency. What can I connect? Right? What was common about all of them? Cost, cost, cost. Right? Income, income, income. So set up a cost equation, set up an income equation. Anything about, like, any part of that you guys want to talk about? Yeah, they did sell 250 long sleeve t-shirts, so there's certainly nothing wrong with saying that, Jet. They just didn't ask for whatever reason. So I just answered the question they asked versus giving all the information. If it said how many of each, then yeah, you'd want to say both. Okay. Next one's a little trickier. It depends on you guys knowing, something about, a common physics formula. Again, it's a very common formula, so shouldn't be anything. It's too big a deal. But again, just first thing I would do is just read through the problem real quick, just get an idea what's happening. So it says flying with the wind, the plane flew 1,000 miles in 5 hours. Flying against the wind, the plane could fly only 500 miles in the same amount of time. They want us to find the speed of the plane in column A and the speed of the wind. Okay? And usually the end of the problem is where you're going to find the question. Okay? So even though it's not a question, right, it's still telling us what they want us to know. So if that's what they want us to know, that's what our variables need to be. Here are the things we don't know: how fast the plane is moving, how fast the wind is moving. Okay? So those are the things we want to find. Again, you get to decide what letters you're using. You get to decide what order you're writing them in. But those are the questions. Those are the things you have to be looking for. Okay? I'm looking for the speed of the plane. I'm looking for the speed of the wind. So that's how I'm going to define my variables. Generally, I just grab the first one first, right? I put that first. The speed of the plane is what they said first, so that's what I write first. But that's really the only reason. Again, your variables need to represent the questions. What are you looking for? Be specific, right? It's not the plane. It's not the wind. You're not looking for the plane. You're not looking for the wind. You're looking for how fast they are, right? So again, this is, we're asking you guys to, or expecting you guys to know a pretty common formula, right? We're talking about distances, and we're talking about times, we're talking about speeds. How do we relate distance and time and speed? Speed equals distance over time, okay? So there's that. Is there a way we could write that without having a fraction, Connor? A different way to say that same formula but without a fraction in it? Speed times time equals distance, right? Distance equals speed times time, or distance equals rate times time, right? And that dirt formula, right? D equals RT, distance equals rate times time. Given the choice, right, having an equation without fractions in it, it's probably gonna make things easier on us, right? So just think about it that way. But yeah, that's how we relate rate and or speed and time and distance. Okay. So how do I build these equations based around this formula? Okay. So what's the consistency here? What's the connections here? Okay. Well, we have a distance. We have a time. What we don't have is the speed, right? So we know this, but we're not sure about that. But there's something else that's happening here, right? This plane is flying with the wind. So we have the distance that it goes with the wind, okay? So the idea here is that, if the plane's flying at 20 miles an hour and the wind is blowing at 5 miles an hour, it's pushing it. The idea is that the plane would be able to go 25 miles an hour. They would just add. Okay? It's not quite that simple, but okay? In real life, but that's the idea. So if I could take the speed of the plane and add it to the speed of the wind, I should get the combined speed of the object. Okay? So that's what I'm going to do here. I'm going to take that distance that I have. Oops, that's what I meant to use. Okay? So with the wind, that distance and the time, so 1,000 equals, okay? But I'm going to take that speed of the plane, I'm going to take that speed of the wind, and I'm going to add them. That should give me the combined speed, right, of the plane with the wind. And obviously we'll need to simplify that. I'll do that in a second. And against the wind, so if the plane's flying 20 miles an hour and then the wind's blowing 5 miles an hour in its face, it should slow the plane down. Again, the overly simplified version, because of a lot of other things going on, is that we would just take the speed of the plane minus the wind. Okay? So it's almost the same formula, except for now the plane wasn't able to go as far. It's only able to go 500 miles, but at the same time, right? It says the same amount of time, so that 5 isn't changing. Now I take the speed of the plane minus the speed of the wind. So, it definitely matters what order you wrote these in. So if you said the speed of the plane was y and the speed of the wind was x, then your equation here would definitely need to be reversed, right? X minus y is not the same thing as y minus x. So what you have here is very important. Okay? And make sure you have this in the right order. So I just need to simplify those, and we'll see how we can solve it. So 5x plus 5y. This will be 500 equals 5x minus 5y. But this one should be pretty much just yelling at you to do elimination because you already have those opposite coefficients here that we want. Those are ready to cancel right now. Okay? So I'm just going to go ahead and add those two equations together, cancel out that y value, and I can figure out what x is. 1500 equals 10x. Dividing by 10, we would get 150. Since we defined x as the speed of the plane, now we think we know how fast the plane is going. We just need to figure out how fast the wind is moving. So, pick one of these equations here, solve for y. I'm just going to use the first one. So 5 times 150 is 750. So I'm going to subtract 750 to the other side. That'll give me 5y equals 250. I'll write that down. Okay, so I subtracted 750 to the other side. Divide by 5. Y would equal 50. There, I think I have the answers, 150 and 50. I'm going to use a matrix to check that. You will have to use this one. You can't use this, write your matrix. So what would our first row of our matrix be? 5, 5, 1000. What would our second row be? 5, negative 5, 500, right? They're just going to plug that into the RREF calculator. Hopefully we get 150 and 50 as our answers. So then we'll know we can wrap up. That's a 2 by 3. Makes computer noises. All right, there's the 150, 50 like we thought. So 1, 0, 150, 0, 1. That checks what we said. Then we can go and answer the question, right? Find the speed of the plane, find the speed of the wind. So should be 150 and 50. Plane speed is 150 miles an hour. The plane is going 150 miles an hour. I'll say the wind is blowing. So something like that. Just again, a short answer. refer back to the questions. Anything feeling weird yet? Brooklyn, you doing okay? Elijah, Kenzie? Thanks, Brooklyn. All right, Natalie? What's the last example I want to go over with you guys? Again, what I would do is just read over the problem real quick, just try to get a feel for things. Okay? Connect a Roku to a television set. You need a special cable with connectors at both ends. Suppose you buy a 6-foot cable for $15.50, a 3-foot cable for $10.25. Assuming that the cable is just the sum of the cost of the 2 connectors and the cost of the cable itself, what would we expect to pay for a 4-foot cable? This one's a little bit less clear in what the question is, like as far as what's the variables, what we don't know. It's not just like stating it like straight up, because it asks this kind of this sideways question here: how much might a 4-foot cable be? We got to interpret a little bit more here what we're actually supposed to be finding. Like, what don't we know? Okay. So overall, what we don't know is the cost of a cable. Well, they're kind of giving us this idea, like assuming that the cost of a cable is the sum of the cost of the 2 connectors and the cost of the cable itself. Here, they're kind of giving us this, what we need to find. Right? Those are the things we don't know. How much does the cable cost? How much do the connectors cost? Because if I know that, then I should be able to figure out how much any length cable costs. Right? If a connector is $20, so I have to buy 2 of them, and then cable's $5 a foot, then I would just say, well, 5 times 20 is 100. So $140 for a cable, right? That's 20 feet long. Okay. So what don't we know? Right? We don't know how much a connector costs. We don't know how much the cable costs. Right? And generally, when you're looking for things, you're looking for them in their units. Okay? If you're thinking about like buying gas, you're thinking about going to the store and buying fruit, you're thinking about getting a job, like talk about things in units, right? How much does 1 gallon of gas cost? How much does 1 pound of fruit cost? How much would you make for 1 hour of work? Right? Those are called unit costs, unit prices. Okay? So I wouldn't define my variable as the cost of 2 connectors. I would define my variable as the cost of 1 connector. Okay? How much does 1 connector cost? Right? In the same way, I wouldn't define, how much 6 feet of cable costs or how much 3 feet of cable costs. I would define how much 1 foot of cable costs. That way it'd be very easy to figure out how much 5 feet would cost or how much 10 feet would cost. Okay? So those are called unit costs. Right? How much is 1? That's usually what we want to know. Okay? So then how would I write an equation about this 6-foot cable? How would we turn that information that they give us about a 6-foot cable and turn that into an equation? So L, when you say 6x, that means you're talking about 6 connectors. Right? 6y, okay? Okay. I was saying 2x plus 6y, so 2 of these plus 6 of this should give us that, right? If it's just cost of the connectors plus the cost of the cable, right? That's all we have to pay for, right? And we should take 2 of these and 6 of this, 6 feet of cable, and give us the cost of the cable. Right? So they're kind of assuming here that there's no like labor here, right? That we don't have to pay for it to be assembled. But again, that's an assumption, but we don't. So 2 connectors plus 6 feet of cable should equal the cost of that cable. We need 2 equations. We can't figure it out with one equation. So how do we figure out with a 3-foot cable? What would our equation be? Okay. Yeah, 2x plus 3y equals 1025. So a little bit more interpretation we have to do there, right? As far as figuring out what they want us to find. How should we solve this? Okay, what do we need to do to make that happen, Ella? Multiply the bottom row by -1. Okay, so that's just going to change all those signs. So if I multiply the bottom row by -1, it's just going to change all those signs. And I can just add it down. Those x's should eliminate. I'll multiply the bottom equation by -1, change all the signs, right, and then add down. So we get 3y equals, what's that, 4, 5, 25? That's y equal to then. $175. Okay. Y is equal to 175, so we just need to plug that back into one of those equations. Which one should we use? Okay, yellow. What's that? I know who said something. Okay. Top one, okay. So we got 2 times x plus 6 times 175 equals 1550. That's not a word. What's that? $9? 6 times 175? Is that right? No. 1050? 1050? $10.50, so subtracting $10.50, this should give us 2, or sorry, 5. That'd be $2.50, right? So we think it's $1.75 and $2.50. Yeah, we should just check that with the matrix real quick. So 2, 6, 2, 3. That will work. I remember from doing this first hour that those were the right answers. So we would get 1, 0, 250, and 0, 1, 175. So it'll check out. So the question here is a little bit different, right? They're asking us how much is a 4-foot cable. It's not just how much are the connectors, right? So what would we expect to pay for a 4-foot cable? So make sure you're answering the question, right? So a 4-foot cable would be 2 connectors, so 2 times 250 plus 4 feet of cable, so 4 times 175, which would be 5 plus 4, what's that, 4, 3, so 7. A 4-foot cable should cost us $12. We're going to build a 4-foot cable. We need 2 connectors and 4 feet of cable. Right? Just add that up. Again, why it's so important to have your variables defined, right? This is the connector cost. This is the cable cost. So if you have those mixed up, you can have 2 of these and 4 of these. That'll be a much different price. So make sure you're defining your variables. Yeah, I will be on the lookout for this. So you guys are saying that, and this part here. Give that a shot. Come back with questions tomorrow. Then tomorrow you guys will get your review after the quiz on Thursday.